Hi, in this video I'm going to show you how to program 8051 chip. This is AT89S52 chip. The pinouts of this chip is as shown. We need that MOSI, MISO and SCK for our programming, and in this case we will be using Arduino to program that. Now next we need also some components like these capacitors, then crystal oscillator and some LEDs. We also need breadboard and some jumper wires. Now to get started with, we will be using that Arduino as an ISP, so I will be connecting it here. This is the COM port 9. Go for our main programming, then we'll be closing that, and I am using Keli here to program the 8051. So when we open Keli, then we'll go to project, that one, then create new microvision project. We'll be choosing the destination and go to documents and then go to this folder, that Keli, and I will name it LED project. Done. So then it would pop up, then we will write here AT89S52, that one. We are using that one, so we'll be clicking this one. So after that we'll click OK, yes, and we'll be getting that target 1, source group 1, that one. So here we will be creating some new file to write our program. In this file I'm just going to copy and paste some of the code I have copied earlier. This is to include that register 52 for our this chip. This is included, and this is the SFR and all that coding. We have declared address A0 as port. We're using port 2 as our output, so we'll be connecting LED to port 2, which is addressed at A0. So we'll set the value as 1, and it will be delayed for 2 seconds, and again 0 and delete for 2. Okay, we'll make it 1 second for our convenience, it will be better. Now what we'll do is save it, and the name would be LED LED blinking .c. That would be better. It's a .c file. Next we would be building it, clicking there, build, and it's starting linking and build. It has built successfully with 0 errors and 2 warnings. Okay, let's check it out. Minimizing that, we'll be going to that folder, then opening Keli project. Then you can see all those files here. Oh, we forgot one thing. To create a hex file, we have to go to the option there, click on flash, configure flash 2, and then there we have to go to the output section and then click on create hex file and click OK. Now again we have to build. Click on build. Now if you go to the folder, if you open that object, you'll be getting a hex file. Now to upload it, we'll be using a VRDude, which is installed alongside that Arduino. We'll be going to the location where I have installed Arduino. Install program files x89 Arduino. Go to tools. Wait. Sorry, that's not the tool. We'll be going back to Arduino. Then we'll go to hardware. Then tools. Then AVR. Then bin. Yes. There would be getting AVR dude. Where is it? Found it. That's the AVR dude. We need CMD to open it up. So I'll be getting the address, copying it, in command prompt, paste the address. Now you can see all those options available in that area dude. So actually I have saved some which I got from the net on desktop. This one we have to write like that. First we have to specify the C, that means configuration file. C is for configuration. You can see it from there. The capital C is configuration file. So we have our configuration files at D 8051 file.config. I can show you. We'll go to D. There we have 8051 file.config. I will upload it to Google Drive and share the link in the description below. You can download it from there. Now if we look for other file, there is small c AVR ISP. The small c stands for that programmer, to specify programmer type. We are using Arduino as ISP, so we have chosen AVR ISP, and the D is bitrate. That one, bird rate, and that's Small p is the part number, you can see it from there. Small p, that one small p, and we are using it 89S52, and that p is port. That port we are using COM9, so we have written COM9, and then slash e dash e is for erasing, and dash u is for upload. So we will be uploading a flash file, so we'll be writing flash like that, in this format. We'll be writing flash flash, then colon, then w, then again colon, and then we'll be writing the file name. So the name of the file is wait, back, document, we'll be opening Keli projects, LED project.hex. But first we have to copy that, and then go to go back. This is the aviadude.exe. In that particular folder, in the same folder, we have to paste that hex file. There it has pasted. So here we are going to give the name without space. You have to mind it, don't use space in the file name, and if you have, then rename it on that original file. There you can rename that and then type it here. Then when I press enter, let's see what happens. 000. I think something went wrong. It's not getting. Wait. Oh, the reason is that we are not using that this one is actually TX and RX, these two P30. One is this one is RX D, and this one is TXD. So we have to connect these two also, like that. One, this one, that RXD, and secondly this one. So these two wires we have to ground like that. One grounded, these two wires should be grounded. Now let's try again. Okay, now let's do one thing. Reset. Again reconnected. Now let's do it again. Not working. Let's check the connection, if not loose. retry. What happened? Yeah, now it got. I think the connection were loose. It has uploaded, so we can check it now using LEDs. We'll be connecting it to port number 2. So we'll be connecting it to the negative terminal in this one, and again we have to connect the negative terminal with a jumper wire. I think this was loose. It's already been uploaded, so it should work. Okay, let's connect and disconnect. It's not working. Actually the problem is with the LED pins. I have to connect it, the negative to the negative and the positive to the positive, and now it's okay. You can look, it is like okay. Now let's connect and then connect, and you can see that it's working. And what happened? Oh, it's loose. I think it's not connecting to the breadboard properly. So if I do disconnect it, I should disconnect and then reconnect. You can see what it's not working out. So it will be using the reset wire to perform a reset. Okay, wait till I check what's wrong. Okay, I have found two problems. The first one is with the connections and the second one is with the program. We have to include it .c file within this folder. So we have to add item, not exactly add item, we have to, as we have created it earlier, so we have to add existing, and within this we have to add that LED blinking.c, then click on add and then close, and you can see that here is the file which is added like that. Then we have to build. Now it's compiling with 0 errors and 0 warnings, so I hope it's done. So minimize it. We'll be going to documents, Keli, object, open the tags, to that Arduino. Now we'll be uploading the same thing. It's done. But to it, something is again wrong. I will check and again. This time I have created on rebuild all. This one. But rebuild all. Then it has said that creating X file build. Now let's try again. Let's see what happens. We'll go to document, then Keli object, where we'll be pasting it again. Let's try again. And it's done and it's working fine, and we have successfully done it. So now this is so much hurdles to do, so to make it easy I have done one thing. I had programmed a batch file with that written code to do the same work. You can see created one folder and there I've written that batch file. First we would copy that file into D program, then change the directory, copy the file to that hardware AVR bin where the AVR dude is located. The hex file is copied, then after that it will change directory to that AVR dude folder location, and then we run that AVR dude folder location with that flash, that file, and then after uploading it will delete that file in that AVR folder location, then pause to show that it's done. I will be uploading the same to Google Drive and share the link in the description. Again, to make the work more further easy, you can do one more thing like that I am going to show. Like that I created one batch file here. That batch file is like that. It would rename because it has a space in that to represent, and copy that, delete. So and like that I would be uploading also this one too. But remember to change the code here if you use that. If you know how to use batch file, then it's okay. You can also use this directly. Now to make it fully independent, we remove all those connections from Arduino. Let me remove that 4 wires. Now you can see that it has stopped blinking. Now to make it start again, we have to trigger it by using the RST, that reset part, like that. It's not working again. Something again is wrong. This is not supposed to happen. What happened? Wait. Actually the connection was again loose, so when I tried it, then just see that it won't start automatically until we trigger the reset, like that. So to trigger a reset we will need another capacitor, like that. We will be connecting it with the positive and this one, and connecting it with directly like that. Wait till I switch on to turn the power on. You can see it started automatically now with the help of capacitor and reset, and that's how you can make it stand alone. Let's retry. See, every time you plug in the power supply it works. We just used the 2 power supply from Arduino. You can use a voltage regulator and a 9-volt battery to power this up. You can make your own embedded system like that. So thanks for watching. See you soon.